Hi, in this lesson we are going to be looking at the higher maths topic of transformations of graphs, and this is lesson 1 in a series. Today we're going to look at the graphs of y equals fx plus c, that's the ones that have been moved up and down, and y equals f of x plus a, that's the ones that have been moved left or right. So let's have a look. So before I go on and teach graphs, I always like to just test what we can remember about straight lines and quadratics. So there's a series of questions here and we have to match them up to the relevant pictures. So y equals x, I'm just going to go match the equations up to the pictures. So y equals x is your straight line which is perfectly drawn, that every coordinate on the x and y axis match. So that would be this one here. Okay, it's perfectly drawn diagonally between the x and the y axis, and that is your starting point for your equation of the straight line before we start thinking about moving it up and down or altering the gradient. Then I have got y equals negative a half x over here. That's a downward sloping line, and I've only got one downward sloping line, so that one is this one here. Then I've got two lines left. I've got one with y equals 2x minus 3. So the minus 3 means it's got a negative y-intercept, which only matches with that one. And then the last one I've got is y equals 3x. And I've already joined that one up. But y equals 3x goes to your end one here by process of elimination. But also the gradient of 3x is steeper than any of these other gradients. So it would be the one with the steepest line. So just remember that, okay? The steeper the gradient, the steeper your line. Okay, next we're going to look at some quadratic ones. So y equals x squared is the quadratic we always start with, your smiley face shape that goes through the origin. So that is this one over here. Then the next one we do is y equals negative x squared, which is that flipped upside down. So a minus in front we know means it's flipped upside down from either trig graphs or quadratics. Then we have... the next one we should be able to do is the y equals x squared minus 1. That's your quadratic moved down one. And the only one I've got left is this one that's turned on its side. Now, you've left with y equals root x, which is actually the inverse of y equals x squared. And you'll see in a later lesson that I'll do why it looks like that and what the transposition is of the inverse function as a graph. And this brings us on to our trig graphs now. So most obvious one I'm going to start with is your sine graph. So there is your sine graph over here. Your cosine graph would probably be next. So your cos graph would be this one. And then you might be thinking this one here is minus sine x, but I don't have a minus sine x equation. Remember when you move sine or cosine graphs left or right, they start to look a bit like each other. So that one is actually a cos graph that's been shifted. Now this one down here, plus 90, means that that's moved 90 that way. So that's what that one is. That's a cos graph that's been shifted. But it does look very like minus sine x. In fact, it is minus sine x as well. That would be an alternate equation for it. And then the one that's left is y equals x cubed by process of elimination. That is what that one looks like. And it looks a bit like I've taken half of my quadratic and twisted it down the way. So basically, you will have some knowledge of this already from National 5 when you were doing quadratics, when you were doing your sine and cosine graphs as well. We can tell the movement of a graph by its equation, and what we'll be asked to do in this topic is we'll be asked to draw, we'll be given a picture and we'll be asked to draw that moved left or right and up and down. And on your diagram, we have to make sure we mark every single point of interest, be it the turning point or the points on the axis, and we have to write down what those coordinates now are once we move them. So let's just recap what you should know from National 5. So your most basic quadratic graph is y equals x squared. If we stick a plus 2 on that, it means that that graph moves up 2. So it would look like that, and I would change my origin or my turning point from 0, 0, and I would mark it on that goes through 2 on the y-axis. X squared minus 2, remember that one I said moved up 2. This one moves down 2, so smiley face. But your y-intercept is now minus 2. This one over here, when it's a number in the bracket, think of your cos graphs as well. Think of just your equation of a quadratic. Plus 2 means it's gone the opposite way if you think. It means it's actually gone to the negative direction, so it's moved 2 over that way. So it still should look like it's sitting on the x-axis, mine isn't quite reaching it. And that turning point now would be at minus 2, 0. Okay, now I don't need to physically write it as a coordinate when it is a point on the axis. It's perfectly okay to just mark it like I've done there. Then we've got these other movements. So -2 means it's gone in the positive direction. So that's it sitting on the axis but touching it +2. -x squared just means that we have flipped it upside down. You should know that a -x squared is your sad face. 2x squared means that your graph is going to be stretched vertically. Think of the graph of sine x compared to 2 sine x. If you're struggling, it means the top and the bottom bits get taller. So what actually happens with the graph of 2x squared is it stretches and it actually looks skinnier compared to the graph of 2x squared. But it's not that you're shrinking it left and right, it means that you're stretching it. So if you get a coordinate of x equals 1 on the graph of y equals x squared, that would be 1, 1. But now the graph of y equals 2x squared, that would be 1, 2. So the graph is actually stretched. Every single coordinate, the y coordinate part of it moves up, so it's got a bit skinnier. And then last, you've got this one here, which is the type you were doing at National 5. +3 means that your turning point is going to be at -3, 2. So your turning point would be over here somewhere. And you would mark on your diagram that was -3 and this was maybe 2. Now what they might also ask for that one is the coordinate of your y-intercept, which would be plugging in x is 0, giving you 11. So I'd maybe mark that on there as well. So let's try the same again with this equation here. It does look just like half of your x squared graph, to be honest, doesn't it? So if we want to draw the graph of y equals g of x plus 2, means we're going to move it 2 that way. So that graph would be moved 2 there, and I would mark that that point is no longer 0, but it's -2. If there is a minus in the bracket, now, if you get confused with this one, remember a minus out front flips it up and down. So a minus in the bracket must mean it flips, but a different way. So if you've already flipped up and down, all that's left to do is flip left and right. Okay? So the minus becomes, the graph flips over the other way, so it's going to look like that. So it's rotated or flipped over the y-axis. And then the g of x one, is minus is out front, that means it's just flipped completely upside down. And always think back to your x squared or your sine and cosine graphs for those ones. Okay, so let's go on to the real deal now. So I've not told you what the equation of this graph is. It really doesn't matter. It's a cubic function and it's been called f of x. They want you to sketch the graph of f of x minus 2. So this means we are going to move this graph down 2 places. So the coordinate -2, 4, if you move that down 2 places, will become, it will still be at -2, but it will go down to 2. So I'm just going to mark that somewhere there, okay? Your other turning point is 0, 0. If you move that down 2 places, that will become 0, -2. So I'm going to mark that about there. And then the other coordinate they've given us is -3, 0. So -3, 0, if you move that down, it would be -3, -2. So I'm just going to mark that about there. And then I'm just going to draw that same shape. Okay, and then on the diagram, I'm going to mark that that was -3, -2. I am going to just put a -2 there to show that it's cutting at -2. And that new turning point there was -2, 2. So that's what they're looking for you to do on the diagrams. Let's do the same again with another one. So in this one, we've got the graph of g of x, and we're asked to sketch the graph of g of x plus 3. So this one is going to move up 3. So you have a turning point on the origin. So 0, 0 becomes 0, 3. Your turning point of 6, -3, if you move that up 3, becomes 6, 0. So that's actually going to just sit on the axis. And it did cut at 7, 0. So on my new diagram, I'm going to have to mark on 7, 3. So I'm just going to put some marks where I think up 3 would be. Like that. And I'm just going to try and trace that shape. It's not wonderful, but it will do. I've still got a point of inflection, a turning point nice and clearly. And then on my diagram, I need to mark on that that was a 3 for 0, 3. I need to mark on that that was 6, still at coordinate 6. And then this one here, where it's moved up, I'm going to mark that that is 7, 3. So that's me drawing the graph of g of x plus 3. The little hand icon meant that I actually wanted you to try that one yourself, but I didn't notice it and carried on. So the work we've done so far now lends itself to letting you go do the TJ textbook, page 40, questions 1 to 3. The second lesson is on y equals f bracket x plus or minus b. So this is the graphs that have moved left or right. So please remember, if it says plus b, it has moved left, it's gone in the negative direction. And if it says minus b, it's moved right and it's gone in the positive direction. So it's always the opposite of what you expect. So on that wee diagram there, I've got y equals x squared in blue. It's all shunted 2 places left, so that said plus 2 in the bracket. But this is all stuff we know from National 5. So we're going to go straight into doing it. So we have a quadratic graph here with the equation x squared plus 2x minus 8. Part A wants us to get all the points of interest, and then we have to sketch that moved 3 places to the positive direction. So that means we're going to go 3 along. And then we have to sketch the same graph but moved up 5. So the first thing I have to do is find what all these points are. Now, the first 2 that are coloured red, so these ones here and here, they are your roots. So they are when y equals 0. So to get your roots, we're going to factorise x squared plus 2x minus 8. So that would give you x plus 4, x minus 2. If you put that equal to 0, that gives you x is 4, x is minus 4, and x is positive 2. So what that means is that the numbers on here, this one is negative 4, and this one is 2. Next thing it's got is, I'll do your turning point. Your turning point is bang in the middle of 2 and minus 4, which is minus 1. So the turning point is at minus 1, and if you plug minus 1 back into that equation, you have got minus 1 squared plus 2 times minus 1 minus 8, which is 1, take away 2, take away 8, which is minus 9. So your turning point was at negative 1, negative 9. And your y-intercept is just minus 8 because that's just putting x as 0. So if you put x as 0 into here, the first 2 terms become 0 and you're just left with the minus 8. So, having done that, we can now go on to do the sketching bit of the movement. So I'm going to change my pen colour and I'm going to do red for my first graph. So for part B, I'm going to do it in red. So we have to sketch the graph of this moved 3 to the right. So minus 4, 0, moved 3 to the right would be at minus 1. So I'm just going to put a minus 1 there. 2 moved 3 to the right would be at 5. My turning point moved 3 to the right would be at 2. So that's got to be directly under the 2 that's already there. So let's draw this in as best I can. I always find it really hard to get the shape very good, as you'll see when I'm trying to go with another picture. So on my new diagram, I've got that, and I would mark that my turning point is at positive 2, negative 9. And then that point that was 8, I'm just going to mark on that that is now along 3, down minus 8. So yeah, that's my graph moved 3 to the right. They then want you to draw the graph moved 3 to the right and 5 up. So I'm now going to just look at the red graph and move it up 5. Sorry, I said up 3, but I meant up 5. So the root at minus 1 gets moved up 5, so I'm going to put that there. And I'm just going to put a 5 there on the y-axis because I'm not going to have much room to label this all. The other root is going to be moved up 5, so I'm just going to make sure that that's above the 5 but in line. Your turning point was down 8. Now if you move that up 5, so for example 2 minus 9 moved up 5 would take you to 2 minus 4. So it's still going to be down about here. So I'm just going to draw this in as best I can. This green pen's not the best of colours. So I've got that. I'm running out of room here, so I'm just going to at the side put in that this is minus 4. All right, so I can see my turning point is clearly at 2, -4. If you really want to, you could do something like this and draw that in going if you don't have space to do so. And then the last thing to draw on is this coordinate of 3, -8. If I moved that up 5 places, that there, and I'm going to have to do the arrow into that one, that would be 3 - 5 now for that point. No, not 3 - 5. I can't add on 5. It would be 3 - 3. Sorry. Right, so that's that one. And I know it's a wee bit messy. Generally, though, in the exam, they will probably ask you to go straight to part C and just draw the one diagram. I'm just trying to build it up for you. Okay, let's have a look at this question. Right, I know fine well I'm going to run out of space on this one. Right, so we want to find the coordinates of the point of interest. So to get that, we have to factorise the equation, which is x squared minus 2x. So that gives you a common factor of x, bracket x minus 2 equals 0. So x is 0, x is 2. So my roots are at 0 and 2. Your turning point is right in the middle, so that's at 1. If you plug the number 1 into the equation, you have 1 squared take away 2, so 1 take away 2 is -1. So my turning point is at 1 - 1 right now. Okay, so what's going to happen is we are going to move each of these coordinates, because we are sketching f of x plus 3, we are going to move each of these coordinates this way. It's going to move in the negative direction. So 0, 0 will become -3, 0. That will be my new root. And 2, 0 will become -1, 0, because I'm just moving the x coordinate 3 places left. And then 1 - 1 will become -2, -1. So I'm going to just mark these on. So there is my so that's not right. My new root will be at -1. I have to extend my line a wee bit here. And -3, so let's make that there. And my turning point is still level with that one, so there. So let's draw my curve in. Okay. And then I'm just going to label that was -1, this was -3, and my turning point, see, because I'm tight of room, I'm going to put -1 here, and I'm going to put -2 there. So that can still be read down to give my turning point of -2, -1. The reason I'm not writing it like I did over here is because I know I'm going to have to draw another graph on here and I'm not going to have space. So next I have to draw the same graph but moved down 1. So I'm going to change my pen colour and I'm going to move each of these coordinates down 1. So -3, 0 becomes -3, -1. -1, 0 becomes -1, -1. And -2, -1 becomes -2, -2. So literally everything's going to move down 1 place. So let's draw this on. So -3, -1 is here. -1, -1 is now here. And my turning point moved down 1. Well, see if that had been 1, that massive gap for 1 before. I need to try and make the other one look roughly the same. So this here, if I extend my axis, is now -2. It's not to scale. And then what we'll do is I'll draw in a nice kind of curve with my green pen. And we'll draw it like that. Now, this is not the best, but I mean, look at me, I've got experience in this and my shapes are still rubbish. Now, what I need to just make sure is that it's very clear what all these coordinates are. Does that clearly look like -1, -1? It does if I read it along. That looks like -3, -1, and that does look like -2, -2. If you have space, you can write the coordinates beside them all, or you can just match them up with the numbers on your axis, which I'm having to do in that case. Okay, so this graph here, we have to sketch this, but we have to do this too. This is what you're going to be presented with. So +2 means we are moving it 2 that way, right? So we're going to move it 2 left, and then we're going to move it 3 up, okay? So that's what we have to picture happening to each coordinate. So let's take each coordinate. Let's do our turning point first. So 1, -2. If you move that 2 left, that becomes -1. Move it up 3 becomes 1. your other turning point of 7 minus 9, if you move that 2 to the left, that becomes 5. And if you move it up 3, it becomes minus 6. Your root of 8, 0, if you move it 2 left, becomes 6. And then up 3 is 3. And then when you had your y-intercept of 0 minus 3, when you move that, you will have negative 2, and then that will be 0. Right, so what we have to do is kind of just draw this shape where we think it's going to be. Some people might prefer to just draw it and then make the numbers match, but I'm just going to go with what I've said here. So I've got a turning point at minus 1, 1. That was the maximum turning point. So minus 1, 1 would be probably about here, and that's going to be a maximum turning point. So I'm just drawing a wee bit of shape on. 7 minus 9 has become 5 minus 6, so possibly about here, and that's going to become a new minimum. So now I'm going to draw my shape in. So that looks not bad, okay? Then I'm going to mark on my coordinates. So that is now minus 1, 1. This one here is now 5, negative 6. And then I've got a coordinate I'm just going to mark on of 6, 3. So I'm just going to call that bit there. That's my 6, 3. They don't always necessarily ask for these ones. And then the minus 2, 0 is that bit there where it's cutting. So I can just squeeze a wee minus 2 on there on the axis. So yeah, my pictures aren't brilliant, okay, and yours aren't going to be either, but you just have to kind of do your best and have the shape and have it well labelled, okay? Okay, so the work we've covered now allows you to go on and try the TJ Higher Textbook, page 41. And I would suggest trying from question 3 onwards. It's up to you if you want to do question 1. That's the one where it's just identifying what the movements of the graph will be, etc. So thanks for watching. Good luck.